Tonight on the Astronomy Show, Chris Gaynor takes us to RADARSAT International to find out about the launch of their new satellite. Jack Newton tells us about his observatory that is run through the internet. And of course, David Dodge with this month's Astro News. All this and more on the Astronomy Show.
Welcome to the Astronomy Show. I'm Chris Gaynor. Tonight we're going to be looking at RADARSAT, an ambitious new Canadian satellite which is due to be launched later this month from Vandenberg Air Force Base in California. As well, we're going to perform some astronomy online with Jack Newton, who lives right here in Vancouver but uses a telescope in Florida thanks to the internet. Our first item tonight is RADARSAT, which will be inserted into an orbit 800 kilometers high. From there, its synthetic aperture radar will obtain high-quality images for use by ships requiring information on icebergs and shorelines, fishermen looking for fish, resource companies, map makers, governments looking for information on the environment, as well as farmers and other users. RADARSAT images are going to be marketed by a firm which is located in Richmond, BC, RADARSAT International. To find out more about what's going on with RADARSAT, I recently dropped in at the headquarters of RADARSAT International.
Hi, welcome to RADARSAT.
Hi, I'm looking for customer service.
Sure, if you just want to go down the hall and take your first left.
Thanks a lot.
You're welcome.
Hi, I'm Chris Gaynor from the Astronomy Show. Is this customer service?
You bet it is. Come on in.
I've been talking to you about getting some images from RADARSAT of the lower mainland and Georgia Strait.
That's right. So I've been doing some work for you, and what you see here is the Georgia Strait. And here, Vancouver Island and Vancouver. I did some work on an area around Georgia Strait. I bounded our area by 49 degrees north down to 48 degrees north, and from 122 degrees to 124 degrees west. And then I wanted to see what RADARSAT image swaths would come across your area of interest using our standard beam mode, which is 100 kilometers by 100 kilometers. And if you can see that the purple lines here outline each standard frame. So if you wanted to purchase an image of the Georgia Strait, you could have one of these 6 or all 6 of these images in standard mode.
What would the resolution be of these frames?
I believe that it's 30 meters. The nominal resolution is 30 meters.
Okay. Now I understand I also have the option of perhaps ordering something with more resolution but a narrower width.
Okay, we can use fine beam mode, and that gives us a nominal resolution of 10 meters. Now we're looking at the frames that would cover your region if we used fine beam mode. You can see that the image swath is 50 kilometers wide, so it's half the distance of a standard swath, but your resolution is far better. And you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 frames in fine beam.
Okay, what sort of purposes would image swaths like this be used for?
Resource managers, environmental analysts use them to look at various applications like forestry, geology, agriculture. Forestry, fine beam 5 is very good for detecting clear cuts, roads, that kind of thing. Geology, you're looking at structures. Agriculture, you may be doing crop monitoring, that kind of thing.
Okay. Now, do you have any other beam widths you could show me?
I could show you what ScanSAR would do.
Sure.
ScanSAR is 500 kilometers wide. That's why you can't see the whole frame, because 500 kilometers is over here somewhere maybe in Kamloops. But this is what your frame would look like, and you can see that in 24 days, which is the repeat cycle of the satellite, you would have 8 or 9 opportunities to image the Georgia Strait with ScanSAR. ScanSAR is a good beam mode for applications where you want to remonitor an area.
Okay, what would be an example of that?
Coast Guard, trying to do ship detection.
Okay.
If your ScanSAR is used by a place called the Ice Center up north, where they're doing a lot of monitoring of ice flows in order to be able to guide the ships through the ice in the winter.
Okay. Now, once RADARSAT is up and operational, if I came in here and we're looking for some imagery, how soon would it be from the time we sat down with you and worked out what I wanted until the time I took delivery of the product?
Our regular service, that would take about 2.5, 3 weeks to process an order, to acquire it, to get the data turned into an image that you can use, and then to ship it to you. We have other services. You can get it much faster. If you want it fast, we can do it in 2.5 days if the right equipment's all set up. Or we can do it in a week.
All right, well, thanks very much, and this has been very interesting, and I hope everything goes well after the launch.
You're very welcome. Call us soon.
Okay.
Yeah, this telescope is a computer-controlled telescope. It's made by Meade. It's called a LX200 series telescope. It's a 12-inch scope, and this works with the Sky program, as you saw down, or with a computer-controlled hand paddle. I can just merely punch in, say, a Messier number. I'll punch in M13, which is a globular cluster, press enter, and then I'll just say go to, and the telescope will head for that target in the sky. And as you can see, it's slewed in declination and now in right ascension axis. And when it gets to that spot in the sky, it will slow down and stop. And this particular telescope, I will have a CCD camera mounted on the back of it. And when it's woken up, when you phone it, and it goes through a setup procedure, and then you merely select a target, punch on it on the computer, and then it, like you saw here, will go to that target.
How do you communicate with your telescope from Victoria if it's in Florida?
What I do is I use the internet, which of course now is the information highway, and you open an account with the University of Victoria, and then I connect by telephone modem through the University of Victoria, through their computer, into the internet, and I then dial my computer up that's in Florida at the observatory, and it wakes up the telescope, tells me whether it's raining outside, what the weather conditions and temperature and relative humidity are, and then I will open up the observatory. It'll be a roll-off roof, so a motor will slide the roof off. The telescope will be woken up and activated, and then it will seek a target star to sync with the computer, again all through internet. And then once you've selected the target star and sync the telescope, then you would move the telescope onto the object that you wish to photograph. In this case, you're using an electronic CCD camera, and you download the image, which shows up on the computer screen in your home in Victoria here, and then you center up the object, select the exposure that you want, and the rest is history.
You mentioned this has CCD imaging. What's the difference between that and a regular film exposure?
Well, regular film, of course, everybody's familiar. It's silver halide crystals in the film that get chemically changed, and then it forms a latent image. You develop it, and you end up with the picture that everybody sees. A CCD camera, on the other hand, has got thousands of little light-sensitive pixels, and they receive photons and build up an electrical charge, and then that electrical charge is read out by the computer. The new chips that I'm using in the Meade Pictor camera and in the ST8 camera from the States are actually 1.5 million pixels on the little chip that forms the picture.
This seems like quite a new technology for amateur astronomers. Are you the only one doing it at this moment?
I may be the only one in Canada doing it, although there have been pilot projects running in the United States. The Mount Wilson telescope, a 24-inch, mounted on top of the mountain, is being communicated to through the internet for users that wish to pay to use that telescope. Some of the universities have also got robotic telescopes already built, including UVic here in Victoria. They can actually operate the telescope from their homes. So the same technology, although it's a much shorter distance in Victoria, can be turned to much greater distance, for instance, in the Florida connection.
How far away are people from being able to use this type of technology on a commercial scale?
Well, I think the technology is there. I certainly will have other people using my installation once it's completed. I've got lots of friends that have particular projects that they're interested in, and I'm sure that once they know that I have a robotic system, they all have computers, they'll be anxious to tap into that technology.
Really, RADARSAT is a very flexible satellite. The sensor that's on board it is probably world-class. There's nothing really existing today that matches it. And originally the satellite was really conceived on the basis of a lot of activity that was going on in Canada in the frontier regions in the Arctic and off the east coast of Canada, primarily related to oil exploration. So a big focus of the satellite's use was for monitoring ice conditions in these parts of the area. So they would map where the ice was moving, getting a better feel for the impact it might have on oil production or maybe ships transiting through the Arctic. And this picture illustrates the concept a little bit. Basically, you see ice between these green islands, and it's important for the ships to know where they can go through there for sort of optimal routing of the ship. So that was kind of the foundation for the satellite program. But since then, this was back in the early 1980s, and since then a lot of research has been done on potential applications of radar imagery, which is what RADARSAT collects.
Now, radar is superior in that you don't have to worry about clouds when you're taking your images, but how else is radar imagery superior over a good old-fashioned photograph?
Well, the two most important things are probably the fact that it can image through clouds, and also the fact that it is sensitive to surface roughness. And that is one of the reasons why radar has been used quite effectively by geologists who are perhaps looking for new mineral deposits or for looking at places where they might want to do some sort of oil and gas exploration. Because the radar is so sensitive to the surface roughness, you tend to see the mountain peaks standing out very clearly. They can use it to detect where faults are, this type of thing. All of the useful information they use in planning where to explore for minerals and oil and gas. So that's a key benefit of the radar.
I understand that RADARSAT also has application for agriculture.
That's right, or we think it does. We are doing investigations in this area. One of the things that we're looking at right now is the ability to monitor crops at different stages in the growth cycle. And we've been using some airborne data that was collected by the Canada Centre for Remote Sensing in China. And in this particular illustration, we've got a radar image of an area in China. And among other things, what the image is showing is rice crops at different growth stages. Because of the unique conditions in which rice grows, where initially the paddy fields are flooded and then the crop slowly emerges, it's possible to see changes in the patterns and the textures on the image as the crop matures. So we're hoping that we will be able to time the imaging at the right stages so we can actually monitor the development of crops. Other work is being done in that area in Canada as well.
Okay. Now we have a couple of photos here that were taken in Georgia Strait, and could you explain what these might be used for? And
sure, I can do that. In fact, these are simulated RADARSAT images that were acquired using data collected from an aircraft a couple summers ago. And these images were taken in the Strait of Georgia, just off the coast of Vancouver. And there's a number of interesting things that you can see in here. First of all, there's simulations of two of the operating modes that I was talking about. In this particular case, it's simulating what we call the fine mode, which gives you fairly detailed resolution, about 10-meter resolution. This image represents the standard mode, which gives you a little bit reduced resolution at about 25 meters, but covers a wider area, 100 by 100 kilometer square area. You can see some of the features in both of them, but there's typically more detail in this image. But a few things that are interesting here, this bright spot here represents one of the BC ferries that's going between Vancouver and Victoria. And actually you can see a narrow V behind the bright spot. That represents the ship's wake. And so those kinds of features stand out quite clearly under certain circumstances in the ocean. If the weather gets too rough, you tend to lose the signal, but under many of the conditions, you can actually pick out these kinds of targets. Other things that you see include these dark areas in here, which can be related to slicks on the water. In this case, they may be oils produced by kelp beds, but it's the same kind of thing that could be detected if there was a real oil spill or something like that.
Now, the distinguishing feature between the RADARSAT program and the optical programs is pretty obvious. They deal in optics, we deal in radar. The advantage that we have is that we can take images night or day, and we can do a much better job on ice and snow. Optical satellites look at it and they can't make the distinction.
What sort of sales are you expecting once RADARSAT gets into operation?
Well, we're expecting over a 5-year period about $185 million in terms of U.S. dollars, which would translate into about $215 to $230 in Canadian dollars. We use that because the international community happens to make reference to the U.S. dollar. We would expect in our first year, 1996, hopefully we'll achieve around between $18 and $20 million. And then, of course, we would expect it to grow. We have a unique niche, which is nice. The problem or challenge that we have, if you will, is that because radar is a relatively new technology in the remote sensing industry, there is a lot of show and tell that we have to do. In other words, people believe it conceptually, they like the idea, but until they actually see it in operation, you can't expect to get a lot of advanced orders. We've had one or two, and quite significant, I might add, but they're from the very, very sophisticated users who have used experimental radar data and know that it will work. I've said this recently to many others that it is absolutely amazing that a system that was designed in the late 70s and early 80s by the Canadian scientists and engineers will have no equal before the year 2002. They have done a fabulous job in designing a satellite that will be the world's most powerful and flexible, and as a result of it, complex, remote sensing satellite that the world has ever flown, except for military satellites, which cost 3 times as much, before the year 2000. And as we go around the world, which is where we spend most of our time, all over the world, the people in the remote sensing industry are tipping their hats to the Canadians over a great job that they've done. So we are quite different and quite forward in the thanks to the Canadian Space Agency.
Welcome back to the Astronomy Show in the October version of Astro News. Well, as usual, we'll start off with the phases of the moon. We have the first quarter moon on the 1st, a full moon on the 8th, a last quarter moon on the 16th, a new moon on the 23rd, and a second first quarter on the 30th. This month is a fairly important month for the moon. On the evening of October the 8th, the full moon will pass slightly through the Earth's outer shadow. This is called a penumbral eclipse. Now, we're not going to see that from Vancouver. It's only visible from Europe and Asia. But if it were visible from Vancouver, we wouldn't see too much because the Earth's outer shadow is very, very faint, and only the sharp-eyed observer would see anything. The full moon on the 8th is called the Hunter's Moon. Last month we had the harvest moon, and it was named because the full moon allowed more harvesting time after sunset. The Hunter's Moon allows the hunters to extend their hunting after sun goes down. And remember, the fields are now barren of crops, so the hunters can now see their prey a little bit easier. The new moon on the 24th causes the solar eclipse we've been promoting for so long. This eclipse is visible in India and Southeast Asia. Unfortunately, the Vancouver tour has been canceled because of lack of interest. But the eclipse will go on for sure, and in the coming months we'll have a report on the eclipse, because we know there are a number of people within the Royal Astronomical Society of Canada out to see the eclipse, and we'll get a report from them, and we'll tell you in, say, December or so. When it comes to comets, it's either feast or famine. Up until a few weeks ago, there wasn't a comet to be seen in the sky unless you had a very large telescope. Now there are 3 within easy reach of binoculars, or soon will be. Comet Hale-Bopp is still over a year away from its expected showing in the late winter and early spring of 1997. Comet Bradfield is just starting to creep into our northern skies, but only visible in binoculars. And just a few days ago, Japanese astronomers discovered a comet identified as 1995 S1, but subsequently found to be the same comet as 1846 DeVico. This comet was discovered just below naked eye visibility and is now easily seen with the unaided eye if you know exactly where to look under clear, dark skies. I was in Manning Park a week ago and I saw it. It's a wonderful sight. Saturn is that bright star in the east just after sunset. Jupiter's still in the skies. It's low in the southwest in the evening twilight glow. To see Saturn's rings, you do need a telescope. Early risers have spotted the bright star Sirius in the southeast around 4 o'clock in the morning. It's been attracting a lot of attention because it's the brightest star in the sky, and when it's that low to the horizon, it exhibits fantastic color changes. One of the strongest meteor showers of the year takes place this month. The Orionid meteor showers peaks on the evening of the 22nd. The near new moon this month will not be a factor in seeing these meteors. This meteor shower is associated with Comet Halley. Indeed, Comet Halley is responsible for 2 meteor showers, the Orionids in October and the Etto-Aquarids in May. Remember, meteor observing requires no optical aids, but does require a clear, dark sky away from the city lights. Don't forget to change your clocks back 1 hour at 2 a.m. on October 29th. This allows you an extra hour's sleep. Oh, and did you know that Halloween has an astronomical connotation? Halloween is a cross-quarter day. It marks the halfway point between the autumnal equinox in September and the winter solstice in December. Well, that's it for Astro News. We'll see you next month. I'm David Dodge.
The preceding program was produced through the facilities of Rogers Community 4, Vancouver. We want to hear from you and invite you to leave your comments and suggestions on our 24-hour response line message machine. Please call 731-5812.